Find an angle theta between 0 and 360 that has the same sine function as the angle 220 and the same cosine function as the cosine value as 220. So for an angle to have the same sine function as 220, it means that it forms the same triangle with the x-axis as a 220 triangle would form. So let's draw a 220 angle and let's see the triangle that's made between the x-axis and the terminal side of a 220-degree triangle. So this is 90 degrees straight up. This is 180 degrees. This is 270 degrees. And this is 0. So 220 is going to be over here in what we call quadrant 3, 1, 2, 3. And it's going to be between 180 and 270. In fact, we could add, like, if you add 45 degrees to 180, then it's 225. So that right in between, 180 and 270 would be 225. So you know that 220 is going to be just a little bit smaller than that, So probably right here. Except for the terminal side always goes to the origin, Let me just erase that. We'll say 220 is about right there. And here's the point on the terminal side. And then the sine function is defined as the y-coordinate of that point over the radius. So this point on the terminal side is xy. Now, if we think about, this point being on a unit circle, that means this side of the triangle is 1, then notice how the sine function just is y over 1 or just y. So it's just this height here, which is this size would be, this distance here would be y, the y value of this point, xy, and then this would be your x value. So it's also the same as the sides of that triangle formed when you draw a line down from the point on the terminal side of 220 down to the x-axis. You form this triangle, and the sides are y and x, the same y and x that are the point on the terminal side. So if I want to find another angle that has the exact same sine function, it means it's the exact same triangle, but located in maybe another quadrant. So we do know that 180 plus 40 degrees would be 220. So we know the angle as measured from here all the way to here, it's a 220-degree angle. So I subtract off this part, and that makes 40. So that means there's 40 degrees within this little triangle that I'm forming. So if I have a 40-degree angle here, I have a known 90 here, and I have a known side, then by angle side theorem, if I just make another triangle with the same one as for the hypotenuse and some 40-degree angle and same 90-degree angle, then I'm going to come up with the exact same triangle. If I can find and I can find another triangle that has the same, that's congruent to this triangle, then the ratio of the sides will also be congruent, because the sine function is the ratio of the sides of the triangle. So if you have exactly the same triangle, then the sine functions on both those triangles are going to be the same, because sine function is just the ratio of the sides. So note here, so we can draw actually this same triangle in all 4 quadrants. So here's one. I could draw, if I go 40 degrees up this way, then I can draw a line down and make another 90. And if I said this is a point on the unit circle, then this would be 1, this would be 40 degrees, and that would be the same y value, except for this would be a positive y value because we're above the x-axis. This technically, because it was in 3rd quadrant, it would be a negative. The value, y value would be negative. But there is a green triangle that would have the same trig value, but although not the same sign in this 1st quadrant and 2nd quadrant here. Then there's another triangle I can form. The terminal side has to be from the origin going out, and the 40 degrees has to be between the x-axis and the terminal side. And then I can draw a line down to the x-axis, and that would be the perpendicular line to the x-axis. And then, so this triangle also would be congruent. So the blue, green, and black triangles are all congruent triangles. Well, I'm not drawing them to scale, but like, you could draw a congruent triangle in quadrant 1 here. The y coordinate would be here, and it'd be the same y coordinate as a 220-degree angle, except for it's positive. The last triangle I can draw, and these should be all the same exact size, and I'm just not doing them very good job of drawing them. That's why they're not exactly the same. But there's supposed to be 4 congruent triangles. This one having a 40-degree angle here and 90-degree here, but it would have the same angle side. And I'm sorry, there's not an angle side really theorem. I guess what I really mean by angle side is the fact if I know 2 known angles, I could find the 3rd angle. So in other words, I'm saying that this angle must be the same as this one is, and as this one, because they all are the leftover change if you take 90 and 40 away from 180. So actually the theorem that from geometry, that we know these are all congruent triangles because of angle side angle. That's the one that I wanted to quote. Sorry, there is no angle side, I don't think, but technically, if you have angle side, what you do have is angle side angle. Okay, so if we look at this red triangle here, it's going to have the same, it's going to be exactly the same triangle as the triangle that was formed when we drew a line down to the x-axis from the terminal side of a 220 angle. So the ratio of the sides are going to be the same, and so the sine functions are going to be the same. And not only is it the same, but the same in sign, as in like in positive or negative as well. And this 4th quadrant, the red triangle here, this y value, it's actually going to be negative, just like for the black triangle. And that's so it's the blue triangle and the green triangle are not the answers here. The the angles that result from those triangles are not the answers. The answer they want here is the one in this fourth quadrant here. So now it just becomes a matter of, we want the angle whose terminal side lies on this point. Well, that we have to measure that angle going from here all the way over here. And so we do know that if there's 40 degrees between threes total of threes being all the way around the circle would be 360 degrees. So we had to back up 40 degrees to get to this terminal side. So that means that this side is 360 minus 40. And we always do that for angles. We always take 360 minus this reference angle. That's what we call the 40 as a reference angle. To find the actual standard angle here. Well, so it would be 320. Yeah. So the answer here for this first part is 320. And then it says find the cosine function that has the same value as 220. Well, cosine is also just the ratio, is just a ratio of sides of the triangle. So all we need to do is the same thing. We need to build a triangle that's exactly the same, congruent to the original triangle. And then okay, so cosine is equal to x over r. If r is 1, if we're in a unit circle, which we can easily just assume we're in a unit circle, then the cosine is the x coordinate. So really, they're looking for another angle. Or if you want to focus on it this way, find the triangle that would have the same x coordinate as a 220 triangle would have. And so we look at this black triangle, and the x coordinate, which is the side of the triangle that's actually laying on the x-axis here, that is negative because when you look at the number line, you have small numbers which are negative, well, large negative numbers to smaller negative numbers to 0 to then to larger numbers. But anyways, so this side is the negative x-axis and this is the positive. So therefore, this x value is going to be a negative value. So what we need to do is we need to figure out which one of the other triangles would also have the x coordinate, the x side, that side at x, a negative value. Is it going to be the blue triangle, the red triangle, or the green triangle, that has a side of the triangle on the x-axis that is going to be negative? So, and of course, you're looking at this green triangle. This green triangle is going to also have a negative x value. So right here. So we need to measure this green terminal side from 0 degrees, because that's how we would measure it from standard position. So you need to measure it from, from here all the way to here, what angle, as measured in standard position, has a terminal side right here, because that angle is going to form the same triangle between the x-axis as a 220 triangle would a triangle would be formed. So they are going to have the same cosine function. So to figure out this angle here, you have to remember that this was 40 degrees and that all the way across is 180. So it's this angle is going to be 180 minus 40, which is 140, right? Because plus 40 would have been 80, so 140. So there is your answer. All right, I hope that you found this very valuable. Have a great day. Bye.